Okay, good morning class. So today we're looking at trigonometric graphs, chapter 6. In particular, we're looking at trigonometric equations. Alright, so at this point you guys have been exposed to this topic already. And you should have done the odd numbers, okay? But anyway, so you indicated that you had issues, no? So it's trigonometric graphs. It's the three graphs as a marker. Three graphs. Chapter 6, this is examples for exercise 6.8, which on page 211. Okay, so I'm just going to pause the video. I'm going to explain to you something. I don't want the video to be too long. Otherwise, the full lesson can be found in the description box below. Okay, so this is where we're at now. We calculated all these values, and we noticed that this point here will happen every 360 degrees. But remember, this is from 0 to 360. So here, k will be equal to 0. Okay? I'll show you now how this fits in. So for those of you who just joined, or we didn't do the part of the recording, we drew the sine of x graph, and we drew a line for y is equal to a half, and we checked where sine of x is equal to a half. As we indicated, that this graph will continue forever in both directions. Okay, so if you're going to pick up the solution here, the first one, which is 30 degrees, okay, we're going to say it's going to be sine of, sorry, not sine, but x is equal to 30 degrees plus, and this solution is going to happen every 360 degrees. But how do we represent that? We say k 360, or k times 360. Why k? K is your cycles minus 1. Okay, so the first cycle, if you look at the first cycle, it's from 0 to 360. Can you see that? So k is going to be 0 in the first case. Okay? Here I've started adding my first 360 to get the next solution. Not so? No? So then k is equal to 1. Then the next one will be k is equal to 2. And the next one k will be equal to 3. And then 4, 5, 6 and so on. If you go in this direction, this is a negative. So k is equal to minus 1. K is equal to minus 2, minus 3, minus 4, and so on and so on. You guys understand? So x is equal to 30 plus k times 360. Or, you went to purple on the other one. As you can see, this one, that solution was at 150. The next one was at 510. The next one was at 870 and so on. Gave me all a half. That solution is happening every 360 degrees again. So what do we say for that? Or x is equal to, the first one was 150 plus k times 360. Now since I introduced a variable to the sum, I must say where it fits in. Not so? And that is why we say k is an element of integers. K can only be, remember what are integers? Positive and negative whole numbers, okay? It goes all the way to infinity, minus 1, minus 2, minus 3, all the way to negative infinity. Alright, you guys understand? But now in every sum, imagine we must draw this all the time. It will take a lot out of us, not so? So what we do is, this is how we actually do it, okay? Then this is the explanation on how we got the following. So if the sum says you got sine of x is equal to half, sine of x is equal to half, and they ask you to write down the general solution. Okay? If they say the general solution, what we do is The first step is to get the ratio on its own. That's number one. The ratio stand on its own. Then we take the not the co-function, we work out the angle. Okay, we work out the angle. And it will be our reference angle. So work out the reference angle. Okay. So how do we do that? We say sine of x is equal to arc sine of half. So if we put that in a calculator, we say shift sine over half gives us 30 degrees. Okay, so that's my reference angle. Okay. Then what do? We take it to the quadrant. Okay. So this is all stations to level. So we ask ourselves, okay? We forgot to say, we must work out the reference angle, no? But if it's negative, we only work out the positive part of it. Okay? In the next lesson I'll explain to you what we do with the negative. So, as you can see, before we took the arc sine, you see sine was positive. Can you see that? And in which quadrants are sine positive? Quadrant 1 and 2. So now we say, okay, in quadrant 1. How do we get in quadrant 1? And remember, it's just the angle, not some or 360 plus the angle. So it's going to be x is equal to 30 degrees plus k times. Now, when will this solution happen again? How many degrees later? 360. Now you must remember that the period on the sine graph is 360. Not so. What's the period on the cos graph? 360. What's the period on the tan graph? 180. Not so? Yes, with an asymptote, yes. Okay. So, if you now say x is equal to 30 plus k times 360 degrees. Or, how do we get into this quadrant? How do we get in the second quadrant? 180 minus. So, x is equal to 180 minus 30 plus k times 360. And what is 180 minus 30? 150 plus k times 360. You see, it's the same as what we had before. Okay? Where k is an element of integers. In our next lesson, we'll bring it together. It will be part of this one. How we actually apply that k is an element of. Okay? People enjoy the rest of your day. Good morning, class.